Hello everyone, welcome to Neso Academy. In the previous lecture, we understood the basics of literal constants. I told you what a literal constant is in the last lecture. Now we are in this lecture, and the name of this lecture is Types of Literal Constants. In this lecture, we will understand the different types of literal constants we have in C++. So without any further delay, let's get started with this lecture and let's see what are the topics. There is only one topic of this lecture, and the name of the topic is Types of Literal Constants. So let's proceed further and let's understand what different types of literal constants we have. But before that, I want to remind one thing. We have already covered different types of named constants. We learned constant variables, macros, enumerated constants in our previous lectures. In the last lecture, I gave you the basics of literal constants. But now in this lecture, we will understand different types of literal constants. So after completion of this lecture, we will say that we have completed literal constants successfully. So let's proceed further and let's understand different types of literal constants we have. Here is the first type of literal constant, which is the integer literal. Integer literal is a number without any fractional or decimal part. An integer literal represents an integer. Therefore, it does not have a fraction or it does not have a decimal point. Now, let's understand through examples how to represent an integer literal. There are multiple ways in which we can represent an integer literal. We have different notations available to represent integer literals. Let's discuss those notations one by one. The very first notation is the decimal notation. Through decimal notation, we can represent an integer literal. Let's take an example to understand this. Here I have defined this variable a, and the type of this variable is integer. Therefore, this variable can hold an integer. I have assigned this value 10 to this variable a. This value 10 is represented through decimal notation. I am saying this because this is the default way to represent an integer literal. Through decimal notation, we have the range of digits starting from 0 up to 9. So the range of digits is 0 to 9. So this is the decimal notation which we can use to represent an integer literal, and this is the default way to represent an integer literal. I hope this is clear to you. Now let's move to the second type of notation, which is the hexadecimal notation. Hexadecimal notation can also help us to represent an integer literal, and it has a wider range as well. Let's see through an example how to represent an integer literal with the help of hexadecimal notation. Here I have defined this variable b, which is of type integer, therefore it can hold an integer. I have initialized this variable with this value 0x1a. This is the hexadecimal integer literal. Why am I saying this? Here we have this prefix 0x. We need to specify this prefix 0x to indicate that this is the hexadecimal number. So clearly through hexadecimal notation, I have represented this integer literal. Now I would like to mention this that hexadecimal integer literal has the range of digits starting from 0 up to 9 and then from A to F. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. So we have range from 0 to 15. This is the range of the digits which are allowed in case of hexadecimal notation. I hope it is clear to you. Here I have this number 1a. A represents value 10 and 1 is 1. So this is the hexadecimal number. Now we can easily convert this hexadecimal number to its equivalent decimal. You can do this on your own. I hope you already know this. 1a in decimal is 26. You can verify this on your own. So with this, we learned the hexadecimal notation as well. Through this notation, we can represent an integer. Now let's move to the third type of notation, which is the octal notation. Here is how we can represent an integer literal with the help of octal notation. We need the prefix 0 and then we can specify the number. The number in this case is 32. This is the octal number. Through octal representation, it is possible to represent an integer. This value is representing 26 in decimal. You can convert this on your own. The range of digits in case of octal number is from 0 to 7. So it has a limited range. Now let's move to the fourth type of notation, which is the binary notation. Here to this variable d, I have provided this value b1010. 1010 is binary number. This is not the decimal number. I have indicated this with the help of this prefix b. So clearly this is the binary number. So through binary notation also it is possible to represent an integer literal. And the range of digits is from 0 to 1. So there are only two possible digits, 0 or 1. 1010 is representing value 10 in decimal. So with this we learned 4 different notations and we have understood how to represent an integer literal with the help of these notations. Now let's understand what suffixes we have for integer literals. The first type of suffix is small u or capital U. These two represent unsigned integers. So if we want to represent an unsigned integer, then we need to add this suffix small u or capital U. For example, we can specify 10u to tell that 10 is an unsigned integer. By default, all integer literals are signed integer literals. They are not unsigned. If we want them to be unsigned, then we need to specify any of these two suffixes, either small u or capital U. I hope this is clear to you. An unsigned integer is a positive integer. Signed integer represents both positive and negative integers. If we only want to represent positive integers, now we know what we need to do. We need to add any of these two suffixes. Now let's move to the second type of suffix, which is small l or capital L. These two represents long integers. By long integer, I mean a big integer. An integer which is quite big compared to the normal integer. We can represent big integers with the help of any of these two suffixes, either small l or capital L. Now let's move to the third type of suffix, which is ul or lu. We can use any of these two suffixes to represent unsigned long integers. That is, unsigned version of long integers. I would like to mention this that these two are not case sensitive. This means we can uppercase any of these letters or all of these letters. This is the possibility. Now here comes the fourth type of suffix, which is small l or capital L. These two suffixes represent long integers, that is very big integers. If we want to represent very large integers, then we can use any of these two suffixes. Also, we have ull or llu. Again, this is not case sensitive, and these two suffixes represent unsigned long integers. That is, unsigned version of long integers. So these are the suffixes we are available with for integer literals. We can use these suffixes whenever we want, depending on our requirements. So with this, we have learned the first type of literal constant, which is integer literal. Now let's move to the second type, which is floating point literal. A floating point literal is a number with decimal point or a number in exponential form. So a floating point literal represents a number with a fraction or a decimal point, or it can be represented in exponential form. Now let's take some examples to understand how to define or represent a floating point literal. Here is the first example. To std cout, I have passed this value 4.5. I want to print this value. 4.5 is a floating point literal because it has the decimal point. This is not an integer. This is a floating point literal. Precisely, this is the double literal. We have two types of literals, double and float. By default, all floating point literals are double literals. But what if we want float literals? If we want float literals, then we need to specify the suffix f. This means we need to write something like this. If we want that 4.5 should be treated as float, then we need to specify this suffix f. So this is the float value. I hope this is clear to you. The difference between float and double will be clear to you when we discuss data types in detail later. For now, just understand, these are the two ways in which we can represent a floating point literal. If we want, we can pass a double literal to a double variable like this. This variable is of type double, and to this variable, I have passed this value 4.5. So I've passed a double literal to this double variable. This is allowed in C++. I hope this is clear to you. If we want, we can pass a float literal to a float variable like this. This variable is of type float, and to this variable, I have passed this value 4.5 f. This is the float literal. Now, if we want, we can pass a floating point literal in exponential form to a variable like this. This variable is of type double, and to this I have passed this value 5.2 e5. This is in exponential form or scientific notation form. This represents value 5.2 times 10 to the power 5. I hope this is clear to you. So with this, we learned what is a floating point literal and how to represent a floating point literal in C++. Now let's move to the third type of literal constant, which is character literal. A character literal is a single character enclosed in single quotes. Let's take some examples to understand what a character literal is. Here is the first example. I have defined this variable ch of type character. Therefore, this variable can hold a character. You can observe that this variable is holding this character capital A within single quotes. This is the character literal because this is the single character enclosed within single quotes. I hope it is clear to you now. Now let's take one more example of a character literal. Here I have defined this variable new line. Again, this variable is of type character. Therefore, this variable can hold a character literal. I have assigned this character literal \n to this new line variable. Now you might be thinking, this must not be the character literal because this is not satisfying this specific definition. A character literal is a single character enclosed in single quotes, but here we have two characters enclosed within single quotes. We have \, and n. How can we say that this is the character literal? We can say this because this is the special type of character literal, which is also called an escape character. This is specifically called as the new line character in C++. So this is the character literal. I hope it is clear to you now. Now, let's take one more example. Here I have defined this variable digit, and this variable has been initialized with this value 5, which is enclosed within single quotes. This is also the character literal. You should not treat this as the digit because this digit is enclosed within single quotes. So these are some examples of character literals. Now let's consider some facts associated with character literals. Here is the first fact. Character literals are stored as integers. Internally, character literals are stored as integers. This means each character literal has an associated integer. For example, capital A is same as value 65. This value is provided by one standard which is called the ASCII standard or ASCII standard. The full form of ASCII is American Standard Code for Information Interchange. This standard provides various values or integers to these characters. So each character is mapped to an integer by the ASCII standard. If you want, you can search online for ASCII table. In that table, you will identify different characters and their mapping with their integer values. Capital A is mapped to value 65. So capital A is same as 65. You will also observe that capital B is same as 66. Capital C is same as 67. It is always in a sequence. I would recommend you to search online for ASCII table and see the mappings of the characters with their integer values. Internally, all character literals are stored as integers. Now here comes the second fact. Arithmetic can be performed with character literals. We can perform arithmetic with character literals because internally they are stored as integers. We can perform addition, subtraction, multiplication, division just as we perform with integers. For example, here to this character literal, I have added value 1. We know that this character literal is mapped to value 65. So we can replace this by value 65 and we will get 65 plus 1 which is equal to 66. I hope this is clear to you. So with this, we understood what a character literal is and what are some of the facts associated with character literals. Now let's move to the fourth type of literal constant, which is the string literal. A string literal is a sequence of characters enclosed in double quotes. So a string literal is different from a character literal. A character literal represents a single character within single quotes. But a string literal represents a sequence of characters that are enclosed in double quotes. So it can have multiple characters. For example, here I have defined this variable name of type const char star. Don't worry about this type right now. Just understand for now that this type represents a specific string variable. So a variable which can hold a string should have this type const char star. We will learn about this type and the types related to it in the later lectures. Now here I have defined this variable name which can hold a string literal. I have assigned the string literal to it which is Alice. So this variable has been initialized to Alice. We can observe here we have sequence of characters enclosed within double quotes. Now here is one more example. Here I have defined this variable greet, but this time the type is more clear. We have std string. Clearly, it is telling us that greet is the variable of type string. This means it can hold a string. Now here we can observe that this variable is holding this string hello world. This is also the sequence of characters enclosed within double quotes. So these are some examples of string literals. Now let's see some facts associated with string literals. The first fact is string literals have an implicit null terminator. It is important to understand that every string literal ends with a null terminator. For example, hello is same as hello \0. We can say this because every string literal is implicitly having null terminator at the end. Null terminator is represented by \0. This tells us that this string ends up at here. So, hello is same as hello \0. \0 is added automatically. We do not have to add this. This is the null terminator. Now here is the second fact. multiple string literals in separate lines are concatenated. If we write multiple string literals in separate lines, especially in case of cout, then those strings will be concatenated, that is, those strings will be joined. For example, here I have defined this cout object, and to this cout object I have passed these two string literals, and they are in the multiple lines. They will be concatenated. This means they will get joined, and we will get the output hello world on the screen in the single line. So in this way, we have understood string literals properly, and we have understood the facts associated with string literals. Now let's move to the fifth type of literal constant, which is Boolean literal. Boolean literal represents either true or false value. So it has two possible values, true or false. Let's take some examples to understand how to define a Boolean literal in a code. Here I have defined this variable isReady of type bool. Bool is the type. This means this variable can hold a Boolean value, either true or false. This variable is currently holding this value true. This is correct because this is the Boolean literal, and Boolean literal can be assigned to a Boolean variable. This is possible. Now here is one more example. This variable name is isEmpty. Its type is also bool, and it is holding this value false, which is correct. So these are the examples of Boolean literals. Now let's see some facts associated with Boolean literals. Here is the first fact. Behind the scenes, true is same as 1 and false is same as 0. So it is the case internally in the system that true is treated as 1 and false is treated as 0. The second fact is all non-zero values convert to true. All non-zero values are treated as true and 0 is treated as false. Let's take one example. Let's say we have this if construct. Here, in the if construct within parentheses, we specify a condition. Based on the condition, the code within braces execute. If the condition turns out to be true, then the code within braces will execute. If the condition turns out to be false, then the code within braces will not execute. Here we have this condition. We have this value 42. 42 is a non-zero value. Hence, it will be converted to true. So here we will get true. Now we can say that the condition is true. Therefore, this code will execute. So we will get runs on the screen because this is the cout object which is responsible to print this string literal on the screen. Now let's take one more example. Here we have this if construct and the condition here is 0. We know this value 0 represents false, so this will be converted to false. As the condition is false, this line of code will not execute, and as indicated here, this will not run. So I hope it is clear to you what is a Boolean literal and how to represent a Boolean literal in C++. So now we have understood 5 different types of literal constants in C++. We are done with all the types. This means we are done with literal constants. We have understood all the types of constants in C++, and we are done with this lecture also. We are done with this topic, types of literal constants. This means we are done with this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I'll see you in the next one.